All right, eighth period. So these are going to be your acceleration notes. If you rather just go through the PowerPoint instead of listening to me give you a lecture, then that's fine too. These notes can be found on the back of your speed and velocity notes that we took last Thursday. So this is on the back of those notes. You should be on page 2 with those. And then the new handout will be after these notes. So you have 2 places to find these notes today. This is on the back of your speed and velocity notes. And then your new notes is for your new graphs. Okay. So your acceleration, you do need to know your definition, what it refers to, and your equation. So the definition for acceleration is a change in velocity over time. Now, because acceleration is a change in velocity over time, we need to remember what velocity means. So think back to last week. Velocity means speed and direction. So because acceleration is a change in velocity, it can mean a change in speed or it can mean a change in direction. So acceleration actually refers to 3 things, not just speeding up. So acceleration refers to things that are speeding up or getting faster. Acceleration can refer to something that is slowing down or decelerating. But acceleration can also refer to things that are changing direction, like the moon orbiting or a top spinning round and round. It might not be changing speeds, but because it's changing direction, it is experiencing a change in velocity or accelerating. So that's going to be the hardest part with acceleration is remembering that acceleration doesn't just mean to speed up, but it does mean to speed up, slow down, or change directions. Okay? So then we have our equation. Because acceleration is a change in velocity over time, that's exactly what our equation represents. So we have a change in velocity, which means final velocity, what you end with, minus initial velocity, that's your change in velocity, and we're going to divide it by time, or over time. So V final will always come first. This is your final velocity, what you end up with. Your initial velocity is what you start with. A lot of the times, your initial velocity will be 0, starting from rest. So, a lot of times, you'll just have a velocity over time, and that's okay too. So, when you plug in your numbers, you're always going to plug in your final minus your initial velocity, and then you'll divide it by time. Now, if your number is a positive number at the end, such as this example here with 20 miles per hour per second, then you will know that you're speeding up. If your number ends up with a negative number, that just means that your car or your example slowed down. So a negative number represents slowing down, whereas a positive number represents speeding up. Now, the hardest part about acceleration is the units. Because you're already dealing with speed, which is meters per second, and over time, you can't have units cancel out. So your units are going to be meters per second, or we say meters per second squared. Doesn't mean you're squaring any numbers, it just means that your units, there are 2 of them. So for acceleration, you need to remember that your units are meters per second squared or meters per second, whereas your speed is just meters per second. Okay? All right. The next thing that we're going to look at is our graphs. So the big difference here is our y-axis. These graphs are going to look exactly the same as our distance time graphs that we did on Friday. The difference here is our y-axis. So our y-axis in this case is now going to be labeled speed or velocity. Remember, speed and velocity are pretty much the same thing, just one has a direction. So before you start answering questions about these graphs, read the axis. These look just like distance time graphs, but are completely different. Time is still on the x. The good news is there's only 3 graphs you need to remember for speed time graphs. And the first one we're going to look at is a flat line. Now, on a distance time graph, a flat line meant stopped. On a speed time graph, a flat line means constant speed or same speed. And the reason why we can see this as the same speed is we can put fake numbers in here. So 0 is going to be at the bottom. Maybe this is 20. Okay? If we have a flat line at the 20 meters per second mark, you'll notice that it's not changing speed. It's the same speed over time. Only a flat line at the 0 mark will only be stopped, because if you're same speed of 0, you're not moving. So a flat line will only mean stopped if it's at the 0 line on the bottom. Okay, it might not always say 0, but if it's on the bottom, that's 0. That means stopped. Otherwise, it's a constant speed of whatever speed that you're stopped at. Okay? Then we have a line going up and a line going down. In a distance time graph, a line going up meant constant speed. In this case, a line going up is going to show us an increase in speed or a positive acceleration. So this would be if we did a calculation and you got a positive number for acceleration. This means we're speeding up. The line going down, in this case, means slowing down or a negative acceleration. On a distance time, this line meant return home. So they do look very similar and they mean different things. So make sure that you're always reading that y-axis to make sure you know what graph you're reading. There is one same thing. Just like in a distance time graph, we can have multiple lines on one graph. The steepness of the slope will represent a greater acceleration. Just like in a distance time, it represented a greater speed. So the steeper it is, the greater you're accelerating, or the faster you're accelerating. Okay? This is your summary chart. Your summary chart, go ahead and stick a big old star on it, because this is going to be helpful for when you're studying between the different graphs. They're not overly difficult, but they do get tricky when I start to combine them. Always remember to read your y-axis before you start answering questions, because they do look the same and mean completely different things. Once you're done filling in both handouts, your acceleration notes, which is on the back of your velocity notes, and your speed time graph notes, then you're going to head to Teams and complete the assignment there. I will know that this is done because it'll be done before class tomorrow, so we can talk about it before we do our run lab. Tomorrow we will be going outside. Please wear warm and comfortable shoes so we can run and walk and backwards walk for our lab tomorrow. If you have questions, feel free to email me or post it on here on Teams, and I'll be glad to answer it tomorrow in class.